Morning guys, so we're going to do a quick recap of finding areas of compound shapes, trapeziums and parallelograms, a bit on circles and a bit on sectors, just to help you through the 4 sections you've got set on Sparks today. So remember, compound shapes, all it is a combination of all the nice shapes that we've done before. All you want to do is split it into those nice easy shapes. So what I'm going to do is, if I split it this direction, and remember you can split it whichever direction you like, you should get the same final answer. Your workings will just be slightly different. But split this way, I know that this rectangle on the side here is still 3 centimeters wide and it's still 8 centimeters tall. So this rectangle here is 3 by 8, which is 24 centimeters squared. This rectangle here, you need to be careful, all the way across is 7 centimeters. I know the width of this rectangle we cut off is 3. That leaves me with a width this side of just 4 centimeters. So this rectangle here is 4 times 2, that is 8 centimeters squared, in which case your total area is 24, add 8, you get 32 centimeters squared. Okay, and remember it is centimeters squared for area. Right, the next one, again, I'm going to split it this time. If I split it across the top there, what I've ended up with is a rectangle and a triangle. Now for the rectangle at the bottom, it's nice and easy. It's 8 centimeters wide and it's 5 centimeters high, so it's just 8 times 5 is 40. The triangle, be very careful. If the height of the whole shape is 9, the rectangle is 5 centimeters high, so that makes just the triangle itself 4 centimeters high. And the width, or the base of our triangle, is 8. So for the triangle, you're going to do base times height and half it. So 8 times 4 is 32, half of 32 is 16 centimeters squared. And so your total area is just to add the two together. So we're going to do 40, add 16, you get a total area of 56 centimeters squared. Hopefully those first two nice and straightforward. Now, trapeziums and parallelograms. In both of these, I've given you a piece of information that you don't actually need. Sorry guys, just got a little bit interrupted there. So we've got trapeziums and parallelograms. As I said, there is one side in here that I've given you that is not actually needed. So remember, in a trapezium, our formula is a plus b times by h and half it. Now, a and b are your two parallel sides. So that's a and that's b, doesn't matter which way around. H is the perpendicular height between them, so that is the height that makes a right angle with the base. So 4 is actually my height, which means in this case 5 is put in there to see if it can trip you up, in which case we're going to do 6 add 9, that gives me 15. 15 times by 4 gives me 60, and half of 60 gives me 30. I get 30 centimeters squared. Okay, so be very careful not to get tripped up by that. And this, you can type it into your calculator as it is. Just don't forget to put your brackets or you'll get a slightly different answer. Right, a parallelogram, remember, is just a rectangle that has been pushed over slightly. So all you need is, again, the perpendicular height. So that's the one that makes a right angle with a base. And the width, in which case 9 centimeters is not needed because I don't need the diagonal side. In which case, parallelogram is just base times height, so it's 7 times 8 is 56 centimeters squared. Okay. Next one, you've got circles. Now remember, we're doing areas of circles, so first thing to mention is that in a circle, if the measurement goes from the centre to the outside at any angle, okay, as long as it only goes from the centre to the outside, that is your radius. If you've got a circle where you've got a line again at any angle, but it goes all the way across the circle, that's your diameter. So don't get confused between the two. And our area of a circle is pi times the radius squared. So in our case, on this one, you can see that I've got a line that goes from the centre to the outside. So this is my radius, so I just need to do pi times 5 squared. Now for those on a Casio calculator, you're just going to type in shift and the times 10 button gives you pi in case you've forgotten, and then times 5 squared. Now it is going to come up like this. That's if it asks for the answer in terms of pi, that's what you give. If it asks for decimal places, if you press the S to D button just above your clear button there, okay, it will turn it into a decimal, and we're going to always round it. Okay, now in this case, 1 decimal place with a 3, I don't need to round up, so it stays at 78.5 centimetres squared. Okay, on the next one, just like we drew above, this line goes all the way across, which makes it a diameter. So the first thing I need to do is find the radius. Now the radius is only half of that, so half of 12 is just 6 centimetres. So this one is pi times 6 squared. So exactly like you've done before, shift pi times 6 squared, and again press the S to D button. You've got 113 point, and this time if you imagine an imaginary line after the 0, the 9 tells me that I have to round up, so it's 113.1 centimetres squared. Okay, and that's it, area of a circle. Now the only way they can make this trickier is if they give you the answer and ask you to work backwards to the radius. So we write down what we know. I know pi times the radius squared has to equal the area, which it gave us in the question was 201.1. We're then just going to solve this like a normal equation. So to get rid of times by pi, you divide by pi. I get r squared equals, and all I'm going to type in is 201.1 divided by pi. Okay, it does give you a horrible decimal. Use at least 4 or 5 decimal places just to make sure that you're not getting a slightly more rounded answer. And then the opposite of squaring a number is to square root. So r is equal to, and if I click square root, and you can either type in that number, or if you've just clicked square root straight away, you can click answer because it's still in the memory of your calculator. Sorry about that, I'm at school at the minute, so we'll get the occasional bell. Equals 8 point, and we're going to do 1 decimal place, you get 8.0, and that one is just centimetres because it's only a radius you're looking at. Okay, and then our last topic is sectors of a circle. Now remember, this is just a fraction of a circle. So you find the area as though it was a full circle. So pi times the radius is 7, so pi times 7 squared. That would be the whole circle, but because I've only got 60 degrees worth, I times this by 60 out of, and because a full circle is 360 degrees, it's out of 360. And you literally type that straight into your calculators. You did get very good at this just before we broke up. So we got 60 over 360 times pi times 7 squared gives us an answer, and again S to D, you get 25 point, and it's going to be 7 centimeters squared. Okay, reason for the 7 is if you imagine a line after the 6, the number after the line, which in this case is a 5, tells us you have to round the last number up. Okay, 5 or higher you round up. And then if we look at our last question, so this time if it was a full circle, it would be pi times 9 squared, since 9's our radius. We only want 115 degrees worth, so I'm going to do 115 out of 360 times pi times 9 squared. 115 over 360 times pi times 9 squared gives us an answer of 81.8. Tells me that I need to round up, so it's 81.3 centimeters squared. Okay, so that is everything that you're going to cover in your 4 objectives. This one's objective 4, circles is objective 3, objective 2 is your trapeziums and parallelograms, and objective 1 is compound shapes. Just remember, you're aiming to complete a minimum of the introduce section on each of them, and then anytime you've got remaining, you're going to go back and look at deepen and strengthen. I know quite a few of you should be able to get a good deal through deepen and strengthen for all of them. Okay, any problems, message me, I'll show my homework.